Our third learning target for our mole unit is a combination of our first and second. On our first target, we learned how to convert between the number of moles of a substance and the number of particles, whether they be atoms or molecules. In the second learning target, we learned how to calculate the molar mass of a substance, or the number of grams that are in 1 mole. Now we're going to learn how to do mass to mole conversions. In part 1, we're going to be starting with moles and ending in mass. So we're going from moles to mass, while our units are going to be in grams, as grams is a standard unit for mass. So before we start a conversion, let's review our 5 steps in order to do a unit conversion. The first is to put our given over 1. Our second is to draw our next chunk. Our third is to pull our old unit down. Our fourth is to put our new unit on top. And our fifth is to place the numbers based on our relationship or our conversion factor. So let's focus on a general setup going from mole to mass conversions. Our first step, putting our given over 1, would look like this. And because we're starting with mole, that would imply that our given is in moles. My second step is to draw my next chunk. And there it is. My third step is to pull my old unit down. So I'll be taking moles and moving it over and down. And then my new unit goes on top. So because I'm converting to mass, I have to remember to use the unit of grams. And my last step is to place my numbers, which means I have to look at a conversion factor. In our last lesson, we learned that for every 1 mole of a substance, that was equal to the molar mass in grams. And that this number, molar mass, comes from our periodic table. So you were warned in the last target that eventually we would have to be solving or deriving for the molar mass of whatever substance was in question. And here we are. So for every 1 mole of a substance, I'm going to have to determine the molar mass, and this is going to change with every problem that I do. So in our teacher example, I see that I'm given 4 moles of K, or potassium. So I'm going to put my given 4.00 moles of K over 1. My second step is to draw the next chunk. My third step is to pull moles of potassium down. And my fourth step is to put my new unit on top, which is grams of potassium. Now I need to place the numbers. So my generic conversion factor is 1 mole of anything is equal to the molar mass off of the periodic table. So just like before, the number 1 is always going to go with the word mole. And in order to get the number for the top part, or the grams, I'm going to have to refer to my periodic table. So after finding potassium on the periodic table, which is element number 19, I see that the bottom number is 39.0983. I need to round that to 2 decimal places, so this rounds to 39.10 grams. Now, because both of these numbers are on top, I'm going to multiply 4 times 39.1. And my final answer is 156.4 grams of potassium. A visual that we're going to be putting together along with the mole to particle conversions in our next target. So if we have mole in mass. So if we're going from moles to mass, we are going to multiply by the molar mass of the substance in question. So let's do a couple more examples together. So looking at, if I'm given 0.8764 moles of gold, my hidden first step is to actually find the molar mass of gold on my periodic table. So after looking at my periodic table and seeing that gold is element number 79, it has a molar mass of 196.97 grams per 1 mole. So in order to start my problem now, I'm going to follow my 5 steps. I'm going to be putting my given over 1, so 0.8764 moles of AU over 1. My second step is to draw my next chunk. My third step is to pull my old unit down, which is moles of AU or gold. I'm going to put my new unit on top, which is grams. So now I need to place my numbers. My molar mass is 196.97 grams for every 1 mole. So for every 1 mole of gold, it'll have a mass of 196.97 grams. After multiplying these two numbers together, I would get an answer of 172.62 grams. Let's do this one more time, but for O2. So before I begin, I have to find the molar mass of oxygen. So 1 O is 16 grams per mole. So if I have O2, that would be double that, so it would be 32.00 grams per mole. So now I'm able to start my 5-step process. The first step is to put my given over 1, so 2.86 moles of O2 over 1. My second step is to draw my next chunk. My third step is to take moles over and down. And my fourth step is to put my new unit on top. Now I need to place my numbers based on the conversion factor I derived by looking at my periodic table. For every 1 mole of O2, that's the same as 32 grams of oxygen. After multiplying these two numbers together, because both of the digits are on top, I get an answer of 91.52 grams. At this time, pause the video and attempt the other 2 element mass problems on your own. When you're done, press play and check your answers. If you've paused the video and restarted, you may now check your answers on the right-hand side of the screen. If you did not calculate the correct answer, go back and try again. If you did, nice work. Now we're going to move on to compound mass. So, compound mass, you still have to find the molar mass of this compound and CO2. Luckily, we've already done this work. We did it on our last class. So the molar mass of CO2 is 44.01 grams per mole. So I'm going to jot that down here so I don't forget. We still have the same 5 steps. We're going to put our given over 1, so 2.5 moles of CO2 over 1. Draw my next chunk as my second step. My third step is to pull my old unit down, and that's going to be moles of CO2. My fourth step is to put my new unit on top, so it'll be grams of CO2. Now, what I need to do is I need to reference my conversion factor that I calculated in my last class. So for every 1 mole of carbon dioxide that exists, it has a mass of 44.01 grams. Because these two numbers are both on top, that means I'm going to multiply. So 2.5 multiplied by 44.01 is equal to 110.03 grams of CO2. Our last guided example is asking for how many grams are in 1.2 moles of glucose, or C6H12O6. My first step is to find the molar mass. Luckily, I already did this in my last class at 180.18. But I'm going to jot that down here just so I have it on record. So for every 1.2 moles of C6H12O6, I can put that over 1. I'm going to draw my next chunk and then pull my old unit down. So C6H12O6. My fourth step is to put my new unit on top, which is grams of glucose. And then I need to reference my conversion factor, which is 180 grams for every 1 mole. So for every 1 mole of glucose that exists, there are 180.18 grams of it in existence. So after multiplying those two numbers together, because they're both on top, I get an answer of 216.22 grams. At this time, pause the video and determine the number of grams and the given number of moles of calcium hydroxide and sodium chloride on the right-hand side. When you're done, press play and check your answers. By now you should have completed the calculations and are checking your answers. If you got it right, nice work. If you did not, go back and check your calculations. Now we're going to move on to part 2, which is going in the opposite direction from mass to mole calculations. So in this section, we're going to go from mass to mole. So what that implies is that because we're starting with mass, our beginning unit is the gram. And we're going towards mole, so our new unit is the mole. So following the same 5-step process, we're going to put our given over 1, which in this case is number of grams. My second step is to draw the next chunk. My third step is to pull my old unit down. So I'm pulling grams down, and my new unit goes on top, which would be the mole. Then I have to place my numbers based on the relationship. And what we have to remember is that for every 1 mole of a substance, the number of grams is going to change because that's the molar mass. So that's something we're going to have to reference every single problem. So in our teacher example, I have 24 grams of carbon given as my start. So I'll put 24.00 grams of carbon over 1. My second step is to draw my next chunk. I'm going to pull grams of carbon down and put moles of carbon on top. For every 1 mole of carbon, I have to determine the number of grams, and I find that information on my periodic table. So after looking at my periodic table and finding carbon as an element, it's element number 6. The molar mass is 12.01 grams. So because I have a number on top and a number on the bottom of this, essentially a really big division line, I'll be dividing. So after punching it into my calculator, 24 divided by 12.01 gets me an answer of 1.99 moles of carbon. So let's do some problems to, we need a visual first. So if I have moles and mass, but now I'm going the other way, so I'm going right to left, I'm going to be dividing by molar mass. So let's now do some practice problems together. The first step, although it's kind of a secret, is to determine the molar mass of my elements or compounds. So gold, just like in part 1 of this note sheet, is still 196.97 grams for every 1 mole. But now that I'm given 15.0 grams of gold, my numbers are going to be switching places because the units are going to be in different locations. So I have my given over 1 and I drew my next chunk. I have to pull my unit down, put my new unit on top. Then I have to put my relationship into the conversion factor based on the units. So for every 1 mole, for every 1 mole of gold, there's 196.97 grams. So after completing that division, I'll solve for 0.08 moles of gold. Let's do another one. If I'm given 2.1 grams of oxygen, which is O2, how many moles will I have? Well, first I need the molar mass, which just like before in part 1 is 32 grams. My first step in converting is to put my given over 1. So 2.1 grams of O2 over 1. Then my next step is to draw my next chunk. After that, I'm going to pull my grams of O2 down and put my new unit on top. Then it's time to place my numbers based on the relationship. So for every 1 mole of O2, there's 32.00 grams. So after doing the math, which is division, I determined an answer of 0.14 moles of O2. So now what I'd like you to do is pause the video and attempt the other 2 questions over on the right. By now, you should have completed the 2 questions, and now you're checking your answers. You might have seen that I made an error and forgot to change this unit to grams, so this became a mole to gram conversion. So if you caught that, nice work. You can check your answers here. Now we're going to do mass to mole calculations or conversions for compounds. So just like before, we have to find the molar mass of the compound before we start. Luckily, we use this in part 1 and the molar mass doesn't change, so it's still 44.01 grams. My first step is that I have to write my given, which is 6.2 grams of CO2 over 1. Then my next step is to draw the next chunk. I'm going to pull my old unit down, which is grams of CO2, and I'll have my new unit on top, which is moles of CO2. Now I need to place my numbers based on the relationship. So for every 1 mole of CO2, there's 44.01 grams. After completing the division, I determined that I have 0.14 moles of CO2. We're going to do one more together. So I'm given 10.0 grams of glucose, and just like before in part 1 and in our previous notes, the molar mass of glucose is 180.18 grams per mole. So my first step in converting is to write my given over 1. My next step is to draw my line, and my third step is to pull my unit down. My fourth step is to put my new unit on top. And my last step is to place my numbers based on the relationship. So for every 1 mole of glucose, there's 180.18 grams. After doing the division, I determined that I have 0.06 moles of C6H12O6. Now what I'd like you to do is pause the video and determine the number of moles of calcium hydroxide and sodium chloride based on the number of grams given. At this point, we should have restarted the video and are now checking our answers. If you received all of these answers to be correct, nice work. If not, you should go back and check your work. Something I want you to notice, you guys, is that I took the time to write out all of the units, like grams of AU, moles of AU, grams of AU. Those things are required. So, just to really drive this point home, all labels and units are required. They are part of your mark scheme. So please make sure that you are practicing writing them in your problem. So after you're done with your notes, you should be moving on to the practice. And when you're done with the practice, check in so you can check your answers.